Okay, I'll even start the screen recording. Okay, so let us concentrate and start understanding what are prime numbers. So there is a basic definition. There is a basic definition for prime numbers is, right? It is a number which is divisible by 1 and itself only. Okay, it is divisible by 1 and itself only. Okay, so this is about a prime number. For example, right, 2, 3, 5, 7, 11, 13, and 17, and so on, right? These are the things. Guys, just 1 second. ಹಾ ರುದ್ರೇಶ್ ಅವ್ರು ಹೇಳಿ. ಇಲ್ಲ ಬಂದೇ ಇಲ್ಲ. ಯಾವಾಗ ಇವಾಗ ಇವಾಗ ಯಾವುದೋ ಹಾ ಬಂತು. ಎರಡು ಬೇಕಾ? ಇದು ಮೆಸೇಜ್ ಅದು ಕಳಿಸ್ತೀನಿ ರೀ. ಒಂದೇ ಸೆಕೆಂಡ್. ಸಾರಿ ಗೈಸ್, ಜಸ್ಟ್ ಮಿನಿಟ್. ಒಂದೇ ಸೆಕೆಂಡ್, ಮೊಬೈಲ್ ಕಳಿಸಿದೆ. ಇಮೇಲ್ ಐ ಡಿ ಇವಾಗ ಕಳಿಸ್ತೀನಿ. Okay, sorry for the interruption. Okay, let us continue. Now, right, the very basic way to understand or check the given number is prime or not. So there are different kind of examples which comes here, right? Type of examples, right? First one will be like check number is prime or not, right? The next comes is print primes up to n. Then, right, it will ask you to print primes in range. Sorry, print primes. Okay, print primes in range. Okay, now next comes is sexy primes in range. Quite a repetitive examples. These are quite repetitive examples in the interview, right? Find the prime. Let's keep these examples in a tomorrow session. Okay, in the second part. Now let us understand and start working with a very basic logic of a prime number. How do we check the given number is prime or not? Okay, let's start with that. Prime number. Okay, so according to the definition, suppose if I give n is equal to 13, this number must be divisible by 1 and itself. So let's go with how to check, right? This is a prime or not with a name method. One very basic method is, right? First step is generate numbers from 1 to n. So for example, if I take n is equal to 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. Now, right, so what is the step we need to follow here? Divide n by the above numbers. Okay, divide the n, given n, by the above numbers, right? Right, if divisible, then count it. So whenever the number is 13 is divisible by For example, 1, 13 is divisible by 2, 13 is divisible by 3. So like this, you go on checking whether 13 is divisible by, right, any of these numbers. So whenever it is divisible, right, keep on counting it. Whenever it is divisible, keep on counting it, right? Else skip it. Else skip counting. Skip counting. Okay, else skip counting. So what we will do here is, after this, right, once done, once done, check, right, once done, check if count is equal to 2. If we take this 13, right, 13 is divisible by 1, count it. 13 is divisible by 2. No. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13 is not divisible by any of those numbers. Then you check the last number. 13 is divisible by 13. Yes. Then increment the count. The count becomes 2. So, in other words, what we are saying is, in this method, prime has only two prime number, right, has only two factors, right? It has only two factors. With this method, we are checking the number is prime or not. Now in this logic, what happens is, right, when the number, right, n value, when n value is quite big, right, time complexity increases. Time complexity, right, increases to the extreme, right? So that's the reason, right, we avoid this method of, right, to check the given number is prime or not. So have you understood this part? Have you understood this part? Okay, have you understood? Okay, good, good, good. Now we will go with another method, right? We'll go with method 2. In this one, what we will do is, right, in this one, what we will do is, right, here, right, we start generating possible factors of any number. Possible factors, right, possible factors of any number. Possible factors of any number, any number are present in, are present in, right, 2 to n divided by 2, ignoring 1 and itself. If you ignore 1 and itself, the factor possible factors of any number are always present in 2 to n divided by 2. For example, let's take n is equal to 14. So the factors of 14 are 1, 2, 7 and 14. Now, if you ignore these two numbers, right? If you ignore these two numbers, so what are the two numbers we are left with? We are left with 2 and 7. Now, let us take this as a starting point of a possible factor of any number, and this will we will take it as ending point. Okay, so what is this ending point? Ending point is nothing but n divided by 2. 14 divided by 2 is 7, correct? So using this logic, right, let's take a prime example. Let's take prime example. Okay, prime number as an example. So here what we will do is, we will take n is equal to 13. So what are the possible factors? Possible factors of 13. Possible factors of the 13 are 2 to n divided by 2. 13 divided by 2 is 6. It's an integer division. So now what we will do is generate possible factors. Possible factors. So generate the possible factors, that is 2, 3, 4, 5 and 6. These are the possible factors for the given number n is equal to 13. Okay. Now what we have to do is, now, right, follow the steps here. Once you do this, the next step is, right, check if n is, right, not divisible by, not divisible by, divisible by any prime, any possible factor, any possible factor, any possible factor, right, any possible factor, then, right, n is prime, n is prime number. So what I'm trying to say here is, first generate all the possible factors of any number which they give you. Now once you generate these possible factors, check 13 is divisible by 2, which is not divisible. 13 is divisible by 3. Then check 13 is divisible by 4. Then 13 is divisible by 5. 13 is divisible by 6. If 13 is not divisible by any possible factor, then we call it as a prime. If 13 is not divisible by any of these numbers, then we call it as, right, a prime number. Have you understood this logic? Right? Possible factors of any number are always present in half of the given number. Okay, so generate those possible factors. Check the given number is not divisible. So 13 should not be divisible by 2, 3, 4, 5, 6. Then we call it as a prime number. So is everybody clear on this part? Is everybody clear on this part? Okay. If you have doubts, you can ask. Okay. Chalo. So it is clear. Okay. Now we will try to write the code for this. Right. Let us write the code for this. Right. In C language. Okay. Now, right, how do you generate the possible factors? So to generate the possible factors, we will use a loop here, starting from which value? Starting from 2, right? And then till where we have to go? Till I less than or equal to n divided by 2 and I plus plus. So this loop will give you this I variable. This I variable, right, gives you, right, 2, 3, 4, 5 and 6 for n is equal to 13. Okay. So now what we have to do inside this? We need to check the divisibility, right? So you need to check if n divisible by I or not. If it is divisible by any one number, for example 14, 14 is divisible by 2. Assume that I have given n value is equal to 14. 14 divided by 2, it remainder is equal to 0. Now if it is divisible, should I check with the remaining numbers? Should I check with the remaining numbers if number is divisible by any factor? Not required. You can skip. So what we will do? We will use break, right? We will use break, right? If divisible, skip remaining remaining operation as, right, remaining operation as it is not a prime. It is not prime, right? Now, right, once you look at this code, right, there are the control when comes to this, when the execution control comes to this, first thing we are not clear it's a prime or not, because there are two exits are present, right? There are two ways we can come out of the loop. One is when this condition fails, you can come out of the loop, correct? Now another one is when this condition is a true, then you will come out of a loop. So there are two ways, right, to come out of the loop. We don't know why we came out of the loop. So what we will do is we will use one extra variable called as status. We will use extra variable called as status. Initially we will keep it as 0, right? Initially we will keep it as 0. Now whenever this condition is a true, what we will do is we will change the value of a status. We will change it to status is equal to 1. Many people will call this variable as status or flag variable, right? Now why are we using this status variable is, I once I come out of the loop at this point, when I come out of the loop at this point, I want to understand for which condition I came out of the loop. Did I come out of the loop because of this condition is true, or did I come out of the loop because of loop condition is failed, right? If I want to understand that once I come outside the loop, so what we need to have here is one status indicator. So now see here, if this condition has become true, obviously the status value will become 1. If the divisibility test, if a number is divisible by I value, if it is divisible, then the status will become 1 and break gets executed, I'll come out. So if the status, once you come out of the loop, if you check the condition, if status, right, is equal to 1, if the status has become equal to 1, don't you think this condition has become true? If this condition has become true, that means the number is not a prime, right? The number is not a prime. So what we can write here is printf not prime, correct? Else what we can do here is, else if the status is still remaining 0, if status is remaining 0, then we came out of the loop because of loop condition is false. If the loop condition fails, that means this condition is never executed. That means n is not divisible by any factor. Then we can call it as a prime number. Then we can call it as printf prime number, right? So understand, there are two ways of coming out of the loop. One is if loop condition fails, I can come out. Another one is if the number is divisible by a possible factor, then I can come out. I want to understand because of which reason I came out of the loop. We are using a status variable. Initially we'll keep it 0, and if this condition becomes true, we will change it to 1. That if once I come out of the loop, I will check the status, what is the value present in that variable. If that variable contains 1, then obviously it is not a prime. Why? Because the number is divisible by factor. Okay, number is divisible by factor. If the status is 0, then you can call it as prime because the number is not divisible by, right, the number is not divisible by the possible factors. Are you clear on this part? Prime number example. Basic example is clear. Okay, very good, very good. Now let us move on to make it better. Let us move on to make it better, right? Now what we will do is code optimization. We will work on optimization. Okay, we will work on optimization. Okay, now for in this logic, what are we doing? Let's take n is equal to 13. So what are the factors, possible factors here? Possible factors are 2, 3, 4, 5 and 6. Possible factors are 2, 3, 4, 5 and 6. Now check, just observe these numbers very carefully. If you are dividing the number by 2, if you are checking the number is divisible by 2, is it required to check the number is divisible by 4? Not required, correct? Now, if you are checking the number is divisible by 2, as well as you are checking the number is divisible by 3, if you are checking the number is divisible by 2 as well as 3, then is it required to check number is divisible by 6? Not required. So you can remove these numbers, and 5 is right in between number, you can remove that number also, because 2.5 into 2 is 5, and this 2.5 comes in between 2 and 3. So that is why we are removing 5 also. Now observe carefully, right? Least factors, least common factors, least common factors are 2 and 3. Now can I check 13 is divisible by 2 and 3 only to decide 13 is a prime? In the first logic, the loop was executing 5 times. The loop was executing 5 times in the first logic, right? But whereas now I can check n is like 13 is prime or not with only 2 iterations, or the loop will execute only 2 times. Now the question comes is, how we have to come with these many iterations, how to reduce the number of iterations. Now, right, instead of n divided by 2, now what we have to do is we need to find 2 to, right, square root of n, square root of n. So in C language, we write the square root of n as sqrt of n. This will help you to select least common factors, least common factors, correct? So but what happens is, when it comes to prime number programs, when it comes to prime number programs, right, they will not allow you to use sqrt function. So what we will do is, instead of writing I less than or equal to, right, n divided by 2, we will write it as sqrt of n. This will reduce the number of iterations. But since in the interviews they don't allow you to use sqrt, now what we will do is we will square on both sides, perform the square operation on both sides. It becomes I square less than or equal to n. Now this can be rewritten as I star I less than or equal to n. So this is the condition you have to write instead of this condition. I'll just put a line here to reduce the number of iteration. So this condition helps to select right? Least common factors, right? So this will optimize your code in a better way. This will optimize the code in a much better way. So what you have to do is, instead of this condition, you have to write I star I less than or equal to n, right? So are you clear about how did we optimize this prime number program, right? So this is how code optimization can be done. Now please do remember that we cannot write a optimized code in one go. We cannot write optimized code in one go. So what we will do is, right, you can write a program here, hash include stdio dot h int main opening bracket. We need one input here, n, printf, enter n value, okay, scanf, right, percentage d double quote comma ampersand n. Once we get the input, call the function, right? Or you can write it here only if you want. We need few more variables, I and status, initially equal to 0. You can write the code here only. For I is equal to 2, I star I less than or equal to n, I plus plus. This will help you to generate the least common factors, right? Then in this one, you check the divisibility test, right? If it is a true, make status is equal to 1, break, come out of the loop. Once you come out of the loop, check if status is equal to 1, you can print that it is not prime, else you can print it as prime, else you can print it as prime. So this is how you can optimize this code. So this is considered as one of the basic logic for, right, a prime number, right? To some extent your code gets optimized. Now if you execute it, right, give 13, it's a prime, give 2, it's a prime, give 14, it's not a prime, correct? So this is one of the very basic code that we should write. So I'll just paste this here so that you'll have it. Okay, so it becomes easy for you to refer. So now the code part is also done. Now we will try to optimize this code using a different algorithm, right? Now there is a person called as a Sieve. There is a person called as Sieve. He has written, right, an algorithm, right, or a definition for a prime number which is more efficient, which is more efficient, which we call it as Sieves prime or Sieves algorithm. Now, according to Sieves, what is the definition of prime? According to Sieves, what is the definition of prime? So, if, right, if the given number if the given number is not divisible by not divisible by prime factors divisible by prime factors, then n is then given n is prime number. Now let us take one example here. Okay, let us take one example and compare our previous logic and the current logic. So previous logic, okay, and Sieves logic. Okay. Now in previous logic, what we have done is, right, let us take n is equal to 107. Okay, n is equal to 107. So if I take, in our previous logic we were performing square root of n. Square root of 107 is, right, 10. Okay, so in this one what we will do, we will generate the least common factors. Okay, 2 3 4 5 6 7 8 9 and 10. Now if you look at this, we will check 107 is divisible by 2 3 4 5 6 7 8 9 10. So total number of iterations are 9. 9 iterations are, right, iterations are required to decide 107 is prime or not. Okay. Now just use a little common sense, all of you. Apart from 2, if you leave the number 2, is there any prime number which is an even number? Apart from 2, is there any number which is a prime number? Never. There are no prime numbers which are even. So what we can do here is, there is no need of checking the divisibility. Number is divisible by 4, number is divisible by 6, number is divisible by 8, number is divisible by 9. These numbers are not at all required. Unnecessarily we are checking the divisibility. So Sieves algorithm, what he is telling is, right, if the given number n is equal to 107, right, so take the square root of n, take the square root of 107, right, which is 10. Okay, right, starting from 2 to 10, choose only the prime number 2 3 5 7. That's it. Choose only the prime factors, the possible factors which are only prime. Now check the 107 is divisible by 2 3 5 and 7. Now how many times the loop will execute here? Only 4 iterations will happen. Iterations will happen. So here I'll write down, choose choose only prime factors. Prime factors. Are you understanding what is the Sieves logic? He is telling you to check the number is divisible by, it is not divisible by only prime factors. No need of checking with some other factors. Check with only prime factors, then we can call it as a prime number. Are you understanding this? Have you guys understood this logic? Okay. Check divisibility by only prime factors. Now the question comes is, sir, how to generate only the prime factors? Sir, we know how to generate this numbers because it is starting from 2, it goes up to 10. But how to skip the, right, non primes, right? So let us start building a logic for it. Okay, let us start writing a code for it so that we will understand how to write a programs. Okay, now I just need little bit space here. Okay, let's start with a program, very basic program. Okay, so hash include stdio dot h. Okay, int main. Now the number of inputs required for this program is only one number, int n. Okay, I will take that n value from the user, enter number. Okay, scanf percentage d double quote comma, okay, ampersand n. I got the number from the user. I got the number from the user. Now what I will do? Now what I will do? I will call a function called as is prime. I am calling a function called as is prime. So what is this function? I'll just write a comment here. Is prime, right? Checks n is prime or not. If yes, returns 1, else returns 0. So it is a user defined function. We will write the function is prime. I will send n as a parameter. Now that function will check whether n is a prime or not. If n is a prime, it will return 1. If n is not a prime, it will return 0. Now, if it returns 1, the condition becomes true. We will print the message as prime. Else, we will print it as not prime. Okay. So our job of this main function is done. There is nothing left to write it in the main function. Now we need to concentrate on building a logic for this function, right? So let us write the function. So since the function is returning 1 or 0 in C language, we will take the return type as int. We cannot take it as boolean because boolean is a data type present introduced in C++, right? In C language we take it as int. Int is prime. How many values are we sending to this function? We are sending only one value, that is n. That is n. Now what is the next step here? The next step is we need to start analyzing boundary condition, right? Analyze boundary conditions. For example, if they give condition as, right, n value can range from 0 to 10,000. N value. So they will give a input as n value 0 to 10,000. Now currently I am bothered about this 0. So what happens when, right, now see here, if I give n value as 0, what does the function should return? If the user gives the n value as 0, what does this function should return? What does that function should return if the user gives n value as 0? Is it a prime or not a prime? User is giving a input as 0. Is it a prime or not a prime? It should return 0 or 1. Sanjana, if the user is giving n value as 0, he will give n value as 0. N value is 0. If he gives n is equal to 0, is it a prime? 0 is a prime number. Is it a prime number? Think. Is it a prime number? All of you. 0. Is it a prime number? It is not a prime number. Correct. It is invalid input. Right? It is not a prime. Suppose the user gives n is equal to 1. If the user is giving n is equal to 1, is it a prime number? Yet if the user gives n value as 0 or n value as 1, right, they are not prime. Correct. So what we have to do is we need to check the boundary condition. If n is equal to 0 or if n is equal to 1, then should I return 0 from the function because they are not prime? If n is equal to 0 or if n is equal to 1, then I will return 0 from the function because 0 and 1 are not prime. Have you understood till this point? Have you understood till this point? Okay, good. Now what we need to do is, let's concentrate on prime numbers. The first two prime numbers 2 and 3, n less than 3. If I write a condition n less than or equal to 3, right? So if I give, can you tell me for what values of n, for what values of n this condition will become true? For what values of n this condition will become true? 2 and 3, obviously. N is equal to 2, condition becomes true. N is equal to 3, condition becomes true. Correct? So if I give n value as 2 or n value as 3, don't you think this condition becomes true? Now if this condition becomes true, can I say that return 1? Because 2 and 3 are prime numbers. These are the first two prime numbers, 2 and 3. If the user gives n is equal to 2, we have to return 1. If the user gives n is equal to 3, we have to return 1 because both are prime number. Have you understood the second condition? Have you understood the second condition? All of you? Okay, all of you, have you understood the second condition? Very good. Very good. Okay. Now, now let's concentrate on the definition of Sieves prime. What does the definition says? What does the definition of Sieves algorithm or Sieves prime says? If the number is not divisible by prime factors, right, then n is a prime number. Now don't you think I need to start dividing the given number with prime numbers, right? So the first prime numbers are 2, 3, right? I need to check n is divisible by first prime number, or if n is divisible by second prime number. If it is divisible, if the condition becomes true, is it a prime or is it not a prime? If the condition is, if the condition is becomes true, the given number, is it a prime or not a prime? Is it a prime or not a prime? Obviously it is a not a prime, correct? If the number is divisible by the first prime number or the second prime number, then definitely it is not a prime number, so we need to return 0. Correct? Okay, correct. Have you understood now? Third condition, all of you guys, have you understood the third condition? Okay, very good. Now the last part is remaining. So we checked number is divisible, not divisible by 2 and 3, or divisible by 2 and 3. Okay. Now don't you think I need to check with remaining prime numbers? 5, 7, 11, 13, right? 17, 19, like that. So I need to check with whether n is divisible by remaining prime numbers or not. Remaining prime numbers, correct? Correct. So now if you look at these patterns, if you look at these patterns, the difference between these two numbers is 2, and the difference between these two numbers is 6. So if you go with plus 2 and plus 6 starting from 5, you can cover all the prime numbers which are present. If you go with plus 2 and plus 6 pattern starting from the prime number 5, you will cover all the prime numbers present as of now. Okay. Now, so what we need to do is, we need to take a loop for I is equal to starting from the prime number 5. So how many numbers we need to select? How many numbers we need to select? We need to select what we need to select? Choose only prime factors. Choose only least common factors. What is the condition for selecting least common factors? I star I less than or equal to n. Okay, we will keep this updating part aside. So we wrote this condition to select least common factors starting from 5. Okay, now what I will do inside this loop? Now inside this loop I need to check the number is divisible by 5 or not. So what I will do, if number mod I number mod I is equal to 0, or number mod I plus 2 is equal to 0. Now can you observe here, starting value of I is 5. Now when I is equal to 5, I am checking the number is divisible by 5. Also I am checking number is divisible by 7. So inside the loop, starting from 5, starting from 5, I am checking the number is divisible by 5, and or I am also checking number is divisible by 7 also. If it is divisible by prime number 5 or prime number 7, then can I say that this number n is not a prime? We have to return 0. Have you understood till this point? We are starting from 5. There is a pattern, plus 2 plus 6. So I started from 5, selecting least common factor by writing this condition. Inside the loop, I will check the number is divisible by 5. Also, I'll check the number is divisible by 7. At a time, I am checking the number is divisible by 5 as well as 7. Right? Have you understood this till this point? Everybody has understood till this point? Very good. Now, so you checked number is divisible by 5 and 7 both. Currently I value is 5. When I is equal to 5, you checked the number is divisible by 5 and 7 both. Now what is the next number I have to check? Next number I have to check is 11 and 13. So currently I is 5. How do you make that I as 13? This is how we make I is equal to I plus 6. I is equal to I plus 6. So second time I value becomes 11 and it becomes 13. So like this, you will go on generating or checking n is divisible by prime factor. So this is what this loop is helping you to check the number is divisible by 5, 5, 7, 11, 13, 17, 19, and so on. Right? And so on. Okay. So, right? So now if I go with from the beginning, the given number is not 0, not 1. Condition fails. Second condition also fails because it is not 2, it is not 3. Third condition also fails. Number is not divisible by 2, not divisible by 3. And this one loop, the number is not divisible by any prime number. Then the control comes to line number 19. If the number is not divisible by any prime and the control comes to line number 19, then can I say that it is a prime number? Then can I say that it is a prime number? Can I say that it is a prime number? Have you understood? Everybody has got? Right? Now let us execute, right? and check, sorry, I variable is not declared inside the function. So let me declare I variable here. So it was showing I variable is undeclared. Okay, so let's give the number 2, it's a prime. Let's give the number as 13, it's a prime. Let's give the number as 14, not a prime. Let's check the number 107, it is a prime number. So is everybody clear on this logic? So I'll take this code and keep it in the writing pad. So any doubts till now? I'll just finish one more example. It takes hardly around 2 minutes or 3 minutes. It takes 2 minutes or 3 minutes. Can we start with that? Okay. Let us start with that. Okay. Now, here there is one more question here. There is something called as sexy primes in a given range m and n. Okay. So first of all, what is the meaning of sexy prime? So it is a pair of primes whose difference is 6. Okay, it's a pair of primes whose difference is 6. For example, if I give the input as m is equal to 1, right, and n is equal to 20, so my output should be, right, 5 comma 11, right, uh, 7 comma 13, right, and 11 comma 17 and 13 comma 19. So this should be my output. So sexy prime means it is a pair of primes whose difference is 6. So you need to print, if I give m is equal to 1, n is equal to 20, you need to print a pair of prime. How many pairs are there whose difference is 6? So like this you have to print. Have you understood the question? Have you understood the question? Okay, very good. Now, so we have already written a program here. So for our program, we need how many inputs? We need two inputs, int m comma n. So we need to enter two numbers. We need to enter two numbers. So if you are reading two numbers, let's take ampersand m comma ampersand n. So this is the starting value, this is the ending value. Okay, now what we will do is we will run a loop. We will run a loop and generate numbers from m to n. Okay, generate numbers from m to n. How do we do that? Generating numbers means we need a loop, specifically for loop, right? I is equal to m, I less than or equal to n, I plus plus. Inside this loop, okay, we have already written a function called as is prime. This function will check the number is prime or not. So what I will do, if is prime of I, okay, I will check is prime of I. Along with this, I will also check is prime of I plus 6 at the same time. So I is starting from one number. Okay. I will check I is prime or not. Also, I will check I plus 6 is also a prime. If both are prime, then can we print the pair like this? So I and I plus 6 both are prime. If both are prime, then print them as pair. Okay. print them as pair. So let us execute it and check it. Let us execute and check it. Oh, there is a problem here. See, are we getting a value out of range? Are we getting a value out of range? Why? Because your loop should traverse till n minus 6. Your loop should traverse from m to n minus 6. Why it has to go till n minus 6? Because we are already checking the plus 6 numbers. We are already checking plus the next 6 numbers inside the loop. So n, the I variable should go from m to n minus 6. So this is how we print all the sexy primes. See, now it is within the range. So I hope everybody has understood today's session.